Hello, in this video we will create our own custom commands which can accept the arguments. And to learn that, we will create our own custom command vertexParticle, which would give you the capability of attaching the particles on the vertices of your own mesh. So here I have a mesh that I have brought in Maya and I run my custom command on it, and it generates the particle system and it attaches particles on each vertex of this mesh. And after that I can apply the dynamics to this particle to create any artistic effect. To do so, we would first understand what is the structure of the command which accepts the argument. So this is an example command, and this command creates a polysphere. And if we would dissect this command, we will find this is the command. This first part, which is a string, is called as command object, which is usually the name of an object. It is also called as command argument. This here, which is a shortcut or the short name for query, is the flag, and true, which is defining the value of this flag, is called as flag argument, which is same for sx and true. Sx here is flag and true here is flag argument. So there are three different terms which we understood after dissecting a command. So if we create a command which accepts the argument and we pass command object, flag and flag argument to it, we need something which can store all these values. With that, we would also need something which can parse this, and we can differentiate what is flag argument, and what is command object. And based on the values of those, we can perform certain operation, or we can use those values. So to understand that, we would understand two different terms, which are msyntax and marg database. So what is msyntax? Msyntax is an object that has collection of flags, flag arguments and command objects. And it helps Maya to accept only those arguments which are defined in this collection. So when I would create the command, I would define what type of flags it would accept, what kind of object and arguments it would accept. And when I will register that command, and during the execution, or when I will use that command and I will pass the flags, Maya will check against this msyntax object that is it an acceptable flag or not. And what is marg database? Marg database is a class that provides us with the function using which we can parse, store and retrieve flags, flag argument and command objects. So this would give us the capability of parsing, storing and retrieving flags, flag arguments and command arguments or command objects. And if we take a deeper dive into marg database, we will see that it is derived from a class which is marg parser. So this class has the capability of parsing and storing flag argument and the objects. And extending this, we get the capability of retrieving as well. So using marg database and msyntax, we can receive the flags, arguments and objects and parse them and store them, and based on those values we can perform certain operations. So now we have the basic knowledge of what needs to be done, how we will be parsing our arguments and how we will be storing them and retrieving them. Now we will go to Maya and start writing the code for the command. Now I am in my Maya session, and the first thing I will do is I will copy the complete code which we wrote in the command video when we created our basic command, and I will paste it in my script editor. And after pasting that, I will start making the changes to the code. So the first thing I'm going to do is I will import one more class OpenMaya FX, because we are going to use the particle system, and for that we need OpenMaya FX class. After importing that, I will also change the name of the command, and I will give the name as vertexParticle. So this would be the name of our command. After that, I will create a function which will create msyntax object for us. And this function will be outside of class. So under command creator function, I will define one more function which I will call syntax creator. In that function, we will do three different things. First, we will create msyntax object, and then we will collect all our flags. And after collecting the flags, we will return this msyntax object. So first thing I'm going to do is I will create msyntax object. And how would I create that? I would create it using OpenMaya.mSyntax, and I would store it in a variable called as syntax. So the first part is done. Now the second part is collect or add the flags. And how we will add the flags? We will add the flags using the syntax object, and function is called as add flag. This function accepts three arguments. First, we will define the short name of the flag, and then we will define the long name, and then if needed, what type of data it accepts, we can define that too. So first, I will define the help flag, because every command should have the help. To define those flags, I will first create the variables for those flags. And those variables will be created outside the class. So for help, we will create two flags, and we will call them k help flag is equals to, it would be defined by h dash h, and there should be a long name for help as well, which is k help long flag, which will be dash help. So we have defined our help flag, and now we will add that help flag in here. So the short name of the flag is k help flag, and the long name is k help long flag. It doesn't accept any kind of argument, flag argument, so we don't need that. Secondly, we will add one more flag which we will call sparse. And this value will define after what gap we would have to add a particle on the vertex. So if we define the sparse is equals to 2, it would add a particle on every second vertex. If we will define sparse equals to 3, it will add the particle on every third vertex. So in the similar way, we will define k sparse flag, and the long name will be k sparse long flag. And what kind of data it would accept? It would accept the double data. So we will define here as a third argument open Maya dot m syntax dot k double. So this let Maya know that this flag will accept the double value, and in the similar way we will define the variables for those. K sparse flag is equals to s, and k sparse long flag is equals to sparse. I will just check the spelling of these. Okay, so we have done our second step of this process, and the third step is to return m syntax, which is very simple. We will just type return syntax. Now the question is how we are going to use this syntax. So we will use this syntax while registering our command. In here we would pass one more argument, which is syntax creator. So when we would pass this syntax creator function, we will accept here this m syntax object, which is very similar to the way we accepted the pointer from the command creator. So in the command creator, we were creating the instance of the class and attaching the pointer, and using the m handle, we are registering that. In the similar way, we would create this m syntax object, and instead of attaching the pointer, we would pass this object itself. And this will be accepted by this m handle. So as the third argument, we passed syntax creator here. Now after that, we can start creating our do it, undo it, and redo it function. But before creating or before writing the code for those functions, we would understand how the undo redo framework of Maya works. So in Maya's undo redo framework, there are two separate queues, or there are two separate stacks. And there is a command execution. So whenever we create or we execute any command, it goes inside undo and redo queue automatically. So first, if we create a polyplane, this would go in the undo queue as well. And then we move it. Then this moving will also go in the undo queue. And then we rotate it. This rotation will go inside the undo queue. And then we press undo. Then this rotation moves to redo queue. And if we would redo it, it would come back to the undo queue. And if we press one more undo, the moving will go to the redo queue as well. So these operations or these executions of the commands would keep on moving from undo to redo or redo to undo based on what you are executing. So this is how, in brief, the undo and redo framework of Maya works. And now we will write our undo and redo functions for our command plugin. First, we would write our doIt function. When the doIt function is called, it receives the list of argument. And this list of argument is in form of margList type object. So we already have one instruction here, which is print doIt, and we have already passed margList, which is a margList type object. The second thing we are going to do here is we will parse this argument list, and we will use a couple of commands for parsing it. So we will put all those commands inside a function, and we will call that function as argument parser. And because it is a part of the class, we will pass self in it. Second argument of this function will be argument list, because we will be passing this argument list, which will be parsed by this function. And inside this function, we will create, or we will use marg database to parse this argument list. So inside this, I will create OpenMaya marg database. And this marg database will take two arguments. The first, it would take the syntax object, and the second, it takes the argument list. And how we will receive this syntax object here? We will use a function that comes with mpx command node, and the function name is syntax. And this function would return us our msyntax object, which we passed to the register command function. So we created our syntax object, we returned our syntax object in syntax creator function, and this syntax creator function returned this object during the register command. And when we will use the mpx commands syntax function, it would receive this syntax object which was passed here. So now we have both the requirements of our marg database. So now we can parse the flag, flag argument, and command objects. And because this marg database has the information of our syntax object and the argument list, that's where it can compare which arguments are acceptable and which are not. And after creating this parser, we will store it in a variable which is parsed argument. And using this, we can perform different operations based on the arguments passed for the flags. So first, I will check if parsed argument dot is flag set. This would help us to check which flag is set. So first I would check if k sparse flag is set. If k sparse flag is set, then parsed arguments, I will just copy it because I would need it multiple times. Parsed argument dot flag argument double, because we know that this argument will receive double value, because we defined it here that it's going to receive the double value. We will use a function flag argument double, and then we will pass the flag. And then we will pass 0, which defines the index of the data, and here the index is 0. If we take a look at the documentation of flag argument double, it defines the flag whose parameter is being required, index of the parameter. And here is the list of functions which you can use to retrieve the value. So we used flag argument double. If it is a boolean data, we can use flag argument bool. If it is an int data, we can use flag argument int. In the similar way, angle, distance, time, string. So these are the functions to accept the value or the flag arguments. So this would give us the value which is passed to k sparse flag, and we want to store it somewhere, and we will store it inside a member variable, which is the member of the class. So we would define it as self parse, and we will declare it inside the class. We would initialize this variable with none value, and then after we receive the value from the argument, from the flag argument, we will set the same value on self.parse. In the similar way, we would define for the long flag. If flag set parse long, retrieve value from k sparse long. So after retrieving this value, function of the argument parser is done. So we would return openMaya dot mStatus dot k success. So we have successfully retrieved our values. So we would, same way we will return it for this if condition. Now, because we also defined two more flags which are for help, we will set the conditions for them as well. So k help flag and k help long flag. And we know that there is no argument associated with this flag. So if someone asks for help, we need to show them the help message. To show them the help message, we will use a function which comes with the mpx command node, and that function is self dot set result, and it would return, or it would output, a string which is passed to this function. And I will do the same thing for the long flag. And before passing that string, I will define it here. Help message. And help message is this command is used to attach a particle on each vertex of a poly mesh. So this is our help message, and you can provide a detailed message which also shows you what are the parameters or what are the flags you can use with this command. So I will pass this help message string to set result function. Now we are done with our argument parser function. So we will use this argument parser function inside our doIt function. I will remove self from here, and because this function is a part of the class, this is a member function, I will use it as self.argument parser, and I will pass argument list to this function. After that, I will check if my self.sparse variable is set to something. Then I will call my actual operation. I will check if self.sparse is not equals to none. If it is not equals to none, then call self.redo it function. And why we are calling redo it function? Because we are going to put our actual functionality of this command, that we will create a particle system, then we will attach the particle to each vertex by reading the vertex position of the mesh. And the reason why we are doing it, because we want to parse these arguments only once, and this functionality of creating the particle system and attaching the particles to the vertices can be done multiple times using redo it function. So that is why we are separating the functionality. So here I will define my redo it function, and I will pass self to it. Okay, so after calling the redo it function, I will return success. So it is important to return the statuses after completion of what you want to do. So I will return mStatus success here as well. Now we will start defining our redo it function, and before writing the code for it, we would understand on the blackboard that what we are going to do here. So what this command does is, if you have a polygonal mesh selected, it would read your selection, or it would read actively selected objects. After that, we would read the vertex positions of the selected mesh. After that, we would create a particle system. And then we will attach the particles on the vertex positions. So first we read the actively selected object, then we read the position of the vertex, then we created a particle system that emits the particle, and then we attached the particle at the position of the vertex of this mesh. So that is what we are going to do in our redo it function. So we are here in Maya, and to retrieve or to get the actively selected objects, we will create M selection list using openMaya.m selection list. After that, we will use a function which is get active selection list. What this function does, it reads all the actively selected object and it adds them in a provided selection list. So the selected objects will be added in mcell selection list. After that, we want to do a couple of checks. If someone or if the user has selected an object, then we will check it using mcell.length length. If the length is greater than or equals to 1, then perform function or further operation. If it is not, then print select a poly mesh. So this would let user know that you would have to first select a polygonal mesh, and after that we would return, because we were not able to execute our operations or the function successfully, we would return openMaya m status dot k unknown parameter. Okay, but if the length is greater than 1, then we want to grab the DAG path of first selected object. So we would also create a couple of more things here. We would first create m DAG path, openMaya.m DAG path. Okay, so we would receive the DAG path of 0th object in the selection list in m DAG path. So now we will have our DAG path of the selected object. After that, because we are going to read the position of the vertices, for the second step we need Mfn mesh, which is the function set for the meshes. Okay, we have created our function set. Then we would, after getting the mDAG path, we will set object for this function set. That means we will attach this object to this function set, so all the operations will be performed on this mesh. So far we have defined if length is 1, then try doing this, otherwise do this. But we have not defined that if nothing is selected, then what to do. We will do the same thing which we defined here. and instead of except now we will use else. So if something is selected which cannot be set as mesh function set, so if a curve is selected, so your length will be greater than 1 and you will be able to get the direct path, but you would not be able to attach that curve to this Mfn mesh function set, which would give you an error, and you would want to see the same print or the same message so that user can understand it. They would have to select a poly mesh. Okay, so we have defined our conditions and we have performed the first part of this function. Now we would read the vertex position of selected mesh now. And to read the vertex positions, I will use a function which is .get points. So this would give me the vertex position of all the vertices of the mesh, and it would give us the vertex positions inside m point array. And we will store that in m point, and we will pass this m point array to this function, and we would pass one more argument that we want to read the world space positions of these vertices. And what would happen if we accept the object space vertices? In that case, if we would create a sphere here and generate the particles, they will always exist at the 0, 0, 0 position, because we are not reading the location of the vertices with the translation applied on it. So for that reason, we will be using, or we will be reading the world space positions. And how we will do that? We'll do that using OpenMaya mspace.kWorld. So now we have read the vertex positions. After that, we would perform our third function here, which is create a particle system. And how we would create a particle system is we will use Mfn Particle System for that, which is the part of OpenMaya fx class. Mfn Particle System is a class that provides you functionality of creating the particle system and retrieving the information of the particle system. And we will store the instance of this class in a variable which is Mfn Particle. Now, using our Mfn Particle, we will create the particle system. So this is the function set, and using this function set, we will create the particle system. And when we will create this particle system, it would return us a m object of this particle system, and we will store that in self.mobj_particle, because we want to keep it as a member variable. We want to keep it as a member of the class. So we have completed our third part. Now we would go to the fourth part, and we will attach the particles to the vertex position. And that's where the role of our sparse argument comes. So we would first create a for loop I in x range, and the range we want to set is the length of m point array dot length. Okay, now at this point we should be able to emit the particle from this particle system. And first, because we want to emit the particle based on the sparse value, we would provide one more if condition. If I modulus self dot sparse is equals to 0, then emit the particle. And how we would emit the particle is using Mfn Particle dot emit, and we would provide the position at which we want to emit this particle, which would be M point array I. After that, we also want to maintain a counter. For example, we want to know how many particles have been emitted based on the number of vertices of a mesh and the sparse value. So whenever any particle will be generated, we will increment this counter. And finally, after the completion of the loop, we will say total points is equals to counter. This will give us the message that many points have been generated. After emitting the particle, we will have to save the initial state of the particles as well. Otherwise, if you would apply any dynamics on it, your particles would never come back to their actual position. And to do that, you would have to use Mfn Particle dot save initial state. So that would set the initial state of the particles, and after applying the dynamics, if you go to the 0th frame or the initial frame, your position of the particles will be restored. And after emitting the particles, we will return open Maya dot m status dot k success. So that should be an ideal code, but because Maya has a bug, and to fix that bug, we would have to add an extra instruction here. At this point, if you will create a particle system and emit the particle, your Maya will crash. And to fix that, we will add one more command here, which is this, which is the same which we already used, but we will also provide the M object of the particle system which was created using Mfn Particle dot create. Because Mfn Particle accepts none argument as well as M object argument. So we have passed M object argument, and by doing so, our Maya will not crash. So to fix Maya bug, ideally, with the normal workflow, we should be able to emit the particle from the particle system. But just to fix that bug, we'll add an extra statement here. And now, before writing our undo function, we would save the script and we will test it first. And I just saw one error here so the variable declared here should not have self. So we will save this code, we will save this script, and I will save it as C drive plugin folder, and I will call it vertexParticle. And I will load this script which is vertexParticle dot pi. So it has loaded fine, and after that I will create or call the command, and the command is vertexParticle, and I will pass sparse as 1. So I have my sphere selected, and I will execute my command with this polysphere selected, and it has created a particle system, and it has given me that it has generated 382 points. And we can hide this sphere and we can see all the points, and they are also placed correctly in the world space. If we have a poly sphere which has very high subdivisions, we can set it to 100, 100. This will generate a very dense particle system. So I select this mesh and I generate it. So it has selected, or it has generated, a very high density particle system, and there are 9,902 particles in it. So that is how we are able to generate our vertex attached particles, and we can apply any dynamics to it. I will set the frame range to 1000, and I will set some of the properties of my particle system, and then I will play my animation. So that is how you can apply the dynamics and create different effects of your shape. You can create a model in ZBrush, which is a very high poly model. You can bring it in and you can execute this command, and it would give you the particle system of your mesh. And as we wrote redo it and do it function, we will write undo it function, and which is undo it, and we would pass self to it. So before I write the code for this function, we would have to set, or we will have to call one more function, which is undoable. We will define this function and we will pass self, and if our command is undoable, we will return true. In this case, yes, we want to return true. Return true. So that would define that our command is undoable. And what do we want to do in the undo function? Just for the demonstration purposes, I would print undo, but when you are printing or when you are writing your own actual command, you can avoid using this print statements, because the print commands slow down the speed of your operation, because they are printing the strings every now and then. So try avoiding printing the print statements. Now I will start defining the undo function. And what we want to do in undo function is that we want to delete the particle system which we created using redo it or do it. So to delete the particle system, I will use a DAG modifier. Because we are modifying the DAG, we are deleting a node, we will use a modifier that modifies the DAG. And that DAG modifier is OpenMaya mDAG modifier. And I will store it in mDAG mode. After creating mdag modifier, I will use a function which is mdagmod dot delete node. So this dag modifier is like a stack. You keep on filling the operations you want to perform in that stack, and when you are done, you call a function which is doIt function of the dag modifier. And as soon as you call the doIt function, it would pull those operations one by one and execute all those operations until the stack is empty again. So in this case, we want to fill, or we want to push only one command, which is delete node. And after that, I will call mdagmod.doIt, which will delete the node. And after deleting the node, I will return openMaya.mStatus.kSuccess. Okay. And what do we want to delete here is we want to delete our particle system which we created here. Okay. I will take it and put it here. Delete node. But if I would execute this, there is a problem. If we see the definition of create function, it says that it creates a particle system with a transform node. So if we will delete this particle system, that transform node will stay inside our DAG, inside our scene, and we don't want to collect the clutter in our scene. We want to keep our scene clean. To delete that transform node, which is the parent of this particle system, either we will have to find out the DAG path, or we can use a function set which works on the DAG node. So in this example, we will use a function set which works on the DAG node. And I will store it in a mfn DAG node variable. To which object do we want to perform this mfn DAG node function set on? We want to attach this function set to our particle system. And using this function set, we will find out the parent of this particle system, which is that transform node. And how we will find out the parent of it is using dot parent. Simple. We will pass one argument to this function, which is 0, which means I want to find out the immediate parent of this node, which will be the transform node. And when we will delete that transform node, this particle system will be deleted with that as well, because it is a child of that. So in that way, we will delete our particle system with its transform node whenever user undoes the command. Now I will save this script and I will save it as C drive plugins on top of the same script which we used before, vertexParticles. Yes, I want to replace it, and I will restart Maya for the fresh session of Maya, and I will execute this command again, and we will see what undo does. So here I am in the new session of Maya, and I will load my command first, and it loaded fine without error. I will create a sphere and execute the command, and it has created the particle system, which you can see here. So here is our particle system, here is our sphere. And what I would do now is I would press Ctrl Z to undo it. And in this way, we have undone what our command particle command vertexParticle did. So our particle system is gone now. It has been deleted by our undo function, and our undo function is called because we saw the printout here. And what happens if we redo the command again? It says select poly because we need to select the polygon. And if we redo it, it creates the particle system again. So that is how our command with arguments work, and that is how we maintain our undo and redo queue. This video was a little bit longer for a beginner level student, so please watch this video again and again if you did not understand anything. And that's it, and I will see you in the next video. Thank you.